Our fourth lesson in Module 4, where we're going to look at confidence intervals. One might say that we are going to be estimating with confidence. So in statistics, we make a lot of estimations, right? We say, hey, we think, well, so we'll get a bunch of data about a population. We'll say, hey, we have a mean that we calculated, and based on this mean and standard deviation and the sample size, we think that the actual mean of the population is in some interval. And what a confidence interval does is it tells us what that interval is. All right, so that's what a confidence interval is. Because imagine that I sample, I take it right where we take a good sample that represents the entire population of Cleveland High School of students, right? So I have an even amount of juniors, seniors, sophomores, and freshmen. And I try to maybe make sure that they're different in enough ways, right? So that I get enough different people. And then I ask them all, hey, what is your household income, right? I can collect all that data. I can take and find the mean or the average of all that data. And I can say, hey, based on this sample, I think that the average income for Cleveland High School is whatever that mean is, right? Problem is there's a good chance that that's not exactly what the mean is. It's probably close, right? But chances are it's not what the actual mean income is if I was to take the income, if I was actually to poll every single student at Cleveland High School. So what a confidence interval does is it tells us, hey, yes, your calculation is pretty good, but the actual mean is really probably in between this high value and this low value. So that's what a confidence interval is telling us. So in order to create a confidence interval, I need, of course, a mean, which we're going to call x bar. I'm going to need my standard deviation, which now we're going to use sigma, right? So this is the standard deviation of the population. And then I need to know n, which is my sample size, right? We already talked about that. So, but I'm going to actually just go ahead and write this out. So this is our mean. This is our standard deviation. Right here is our sample size. Let's see. And in order to do this with your calculator, you don't really need this, but it is your calculator is using it. And it is what's called a critical value. So those are the things that we need. In our case, it's called Z star. Z star is our critical value. A critical value you can get from a table, from a T distribution. It doesn't matter where it comes from. What matters is how we use it. So we can estimate with different levels of confidence, right? If we are estimating with 90% confidence, so we can say, hey, I have 90% confidence that the mean is in between this number and this number. I will use a critical value of, for 90%, C star is equal to and I don't have this memorized, I would get it from the table. So at 90%, we would use 1.645. All right. And these are the most common confidence. We would do 90% confidence intervals, I should say. 95%, we would use a z value of 1.96. That's the most popular one. 1.96. And the reason why it's the most popular one is because in statistics, a 5% margin of error, I shouldn't say margin of error, but in order for a particular result to be statistically significant, we would want it to have probability that it doesn't occur to be, the probability that it occurs by chance to be just about 5% is the best way to say it, right? The reason why they use 95% confidence is because you would want there to be only about a 5% chance that that result would happen just randomly. All right? And at 99% confidence, we will use 2.5. So when we create a confidence interval, the formula that we use, and you guys aren't going to even have to use the formula, you are going to wind up actually just using your calculator. So our formula for this is x bar plus or minus z star times sigma, our standard deviation, divided by the square root of our sample. So you ask me why 95% is favored over 99%, and you're going to see what happens with these things, right? The higher the level of confidence, the wider my interval is going to be, yeah? So it doesn't actually capture the true mean, right? The less confident I am, the smaller my interval gets. And it makes sense, right? If you're only 50% confident about it, you could be 50% confident that your true mean is in a very small interval. Because you're like, at 50%. If I get it wrong, I get it wrong. If I don't, I don't, right? If you're 99% confident, you're going to have a much wider interval because you're going to have more numbers in there to choose from. Or you could say, hey, okay, if it lands here, I'm good. If it lands way over here, I'm good. If it's actually more in the center, like I think it should be, I'm still good, right? 95% is a nice interval that captures enough estimations of the true mean, but isn't so wide that it gives you too much variation. You know what I'm saying? It's an interesting, weird thing. Because this is going to create actually a set of two numbers that we think our actual mean is in between. So this thing creates that situation. All right? So I think that we should actually do a problem in order to actually get a feel for what this thing does. All right, so let's work on it. All right, so at a cookie factory. All right, so we'll say at a cookie factory, a sample of 150 cookies was taken, and we should really say that this was a simple random sample of 150 cookies was taken. The mean number of chocolate chips in the cookies in each cookie, I should say, right? In each cookie, not in the cookies, but in each cookie. Was, are they big cookies? What do you think?
Big cookies.
They're big, 10 chocolate chips. I like my chocolate chip cookies.
At least like chocolate.
I like them to be like definitely over 50% chocolate. You know what I mean?
There should be at least 12.
I don't need the dough as much as I need the chocolate. You know what I'm saying?
You don't need real cookies except that.
All right. The standard deviation was 3 chocolate chip cookies. 3 chocolate chips, right? So give or take 3 chocolate chip cookies. Yeah. Chocolate chips. I keep saying cookies. Chocolate chips. All right. So have we got all of our stuff? We have our mean. We have our sample size. We have our standard deviation. We are prepared to create a confidence interval. At what level of confidence? So let's go ahead and create a 95% confidence interval. That captures the true mean. The true mean number of chocolate chips. All right, so let's gather our data. X bar is 10, right? And our number of cookies from our sample was 150, right? Took a sample of 150 cookies. And our standard deviation was 3. Confidence level, 95%. That's the information we need. If I wanted to go ahead and make the formula, which really, honestly, just taking these numbers and put them in a calculator is not great, right? You should actually understand what your calculator is doing. So what your calculator is going to do is it's going to calculate this, right? We said that our formula is X bar plus or minus Z star times sigma, our standard deviation, divided by the square root of our sample size. So that means that our formula for this particular confidence interval is going to be 10 plus or minus. We said Z star was 1.96, right? And the last, we said that our critical value was 1.96, and that's going to be times 3 divided by the square root of 150. Right. Let's go ahead and make our calculator do this. Actually, let's do it by hand first and see that our calculator will get this for us. So, first thing I'm going to do is calculate this. This is actually this piece right here. It's not something you absolutely need to know, but this is actually my margin of error. So I'm going to calculate that first. 1.96 times 3 divided by the square root of 150 turns out to be, we have that this is equal to 10 plus or minus 0.48. If we round to the thousands place, that's what we get, right? So we should say, sorry, that's approximate, because we are rounding. So what this does is it yields us an interval, all right? What it says is that the actual mean number of chocolate chip cookies, I'm going to go ahead and do 10, so we should have 10 minus 0.48, comma, 10 plus 0.48. I'm saying, this is not a coordinate, right? I'm saying it's an interval in which x is between these two numbers that we're going to calculate. Write the interval. So that interval is equivalent to 1.48 and 10 plus 0.48, which is 10. So it turns out that the true mean number of chocolate chips is going to be between 9.52 and 10.48 chocolate chips. I think that if I was running the chocolate chip factory, I think I would find that acceptable. We're not off by more than a half of a chocolate chip, right? Which is, I don't know, maybe it's not negligible.
Half a chocolate chip. Sure.
Per cookie? Huh? Less than half of a box. I mean, is that negligible? I don't know. Maybe. How many cookies are you making? It might add up to a lot of chocolate chips.
Could be a lot of chocolate chips left out people's cookies.
Yeah.
How much chocolate chips per cookie are taken?
Huh?
How much chocolate chips per cookie are they putting on?
I think they're trying. I mean, if you're getting a mean of 10, I think that might be hopefully what you're trying for. I don't know. Maybe the machine lets out too many here and there.
I think it's an absolute few that shows that amount.
Yeah.
The mean should be 10. We should be getting, well.
So let's go ahead and use our calculator to calculate the same thing. Now that you've seen the formula, you know what the calculator is doing. Let's go ahead and make the calculator do it. All right. We are going to get out our handy-dandy calculators, and we are going to go to stat, and we're actually going to go over to tests, okay? Stat and then tests, and we have to go down to Z interval, and it's going to ask us, do you use data or do you use statistics? And unless I have a long list of numbers, I'm going to be using my statistics, okay? Data means I have a list of numbers that it wants me to find a confidence interval for, and stats assumes that I've already calculated it. So if I had all of the numbers of chocolate chips and all the cookies, and all 150, and I entered it into a list, then I would be able to use stat, but I don't have that. So we said our standard deviation was 3. Our mean number of chocolate chips was 10, and we got that from a sample of 150 chocolate chips. And it's already asked us for our confidence level, which we said was 95. We hit calculate. And there it is. What do we get? Just about the same after we rounded. There you go. Take that, calculator. I can do my own math most of the time. All right. So let's go ahead and just do one example from your homework, and we'll call it good. So guys, interesting that you're being asked which interval is wider. Based on the information that I told you about confidence intervals, which interval will always be wider?
95.
The 90. Yeah. 90. Remember, as you become less confident in your answer, your interval becomes wider because you have a better chance of actually getting the right answer, right?
Oh, I thought you were telling us that like the more confident, or like the higher the percentage was, the less confident you're about to get. Like 95% confidence means you're searching this area because you're gonna have a high chance of finding it.
Yeah, so, no. Oh yeah, sorry. What did I just say? As your confidence level increases, your interval gets wider. So yeah, so 95 should be wider than 90. Yes. Sorry about that. Sorry. All right. So standard deviation 56.70. Mean is 630.90. We took 32 gas grills. Let's go ahead and construct a 90% confidence interval. All right. We can just do it using our handy dandy calculator. We will go ahead and go to second. No, we will not hit second. We will just hit stat. We will go to count. We will go to tests. Then we will go down to Z interval. Or you could just hit 7, right? We're going to use statistics. Our standard deviation was what? Johnny? 56.70. Our mean was 630.90. All right. How many grills? 32. Our confidence level, let's go ahead and calculate it at the 90% level. Because it says to do 90 and 95. So, the actual mean price of a grill should be between $614.41 and $647.39. Or we should say we're 90% confident, rather, that the mean price of a grill is within that. Simone? All right, that's it.
Yeah.